All right, so let's do lab write-up. You guys are going to play along with me at home and pretend that we didn't just go over this for a couple minutes. But let's play make-believe for a few moments. So yesterday you did a lab, you had a write-up, it ended, or an observation sheet, and you actually did this on your papers. Okay? This is posted on the classroom, by the way, this one sheet that we had from one of the classes that looked pretty good. So when you go to do the write-up, so for box number 4, we had a pinkish, cloudy something. Okay?
That yellow one's yellow, right?
True, but that's something different. So on this write-up, you'll have all of these different equations that you have to figure out. So what we're going to do with that, for number 4, I think is the first one. For number 4, you need to write down what those things are that were combined. Now I'm going to write them down here, the actual names of those things, but if in your write-up you want to just put the formulas, that's fine. But for the sake of doing this from square one, I'm going to say, okay, so we added lead to nitrate. We added to that potassium hydroxide. Right? This is what happened in box 4. Right? These drops that you did in the lab, in this box, you added potassium hydroxide all across here. You did lead nitrate up and down here. So in... All right. So in this box, you had a mix of those two things. So we did, if we were to write this down, this is what happened in that box, correct? So that's where you're going to start with on all these lab write-ups to do these double replacement reactions, right? So now we have to change this into the actual formula. Now this was written on all the bottles in the lab yesterday. Some of you may or may not have figured that out. But right now we have to turn lead 2 nitrate into the formula for lead 2 nitrate. How do we do that? Pb, NO3. What's the charge on lead 2? What's the charge on nitrate? -1, crisscross. Right? Should all be able to get this far, no problem. What about potassium hydroxide? What is that going to look like? KOH. Now we're going to write the candidate double replacement reaction here, right? So double replacement means these two things are going to switch places. That's what a double replacement reaction is, right? So if those are going to switch places, we want to write what those new products are going to be. In this case, we're going to have KNO3 plus PbOH 2. How am I doing so far? Check my work.
Does it matter which side you put the plus on them?
No. So you're saying could these be flip-flopped here? Does not matter. Makes no difference. That's fine. Okay, so now that we have this. What? Where? Okay, so you bring up a great point. Why is this?
Oh, never mind.
Why is this NO3 here and not NO3 2? Where did the 2 go? Yeah, so when we made new products, we had to rebalance whatever these products were. The subscripts over here, anywhere over here, make no difference. All we want is the bits and pieces, the cations and the anions.
Wasn't the 2 only there for blood?
What's that?
Isn't the 2 only there
Yeah, because this is lead 2, right? So, and this is a -1, so we needed 2 of these. But over here, when the potassium and the nitrate are together, they're both 1s. +1, -1. All right, so we need to balance this equation. No. Wait till we're done with this. So we need to balance this equation. How do we do that? Add coefficients. Where do we need coefficients? That does it, right?
No. Wait, maybe? No, the K needs to be for
7 oxygen on the left side and 8 on the right.
What?
Oh, wait, never mind. Never mind.
I thought.
I didn't see the 2.
Of course. The giant 2. All right, so now we have our balanced equation. Now we're not done. Okay? We have to identify what is our precipitate here. How can we find that out? Purple sheet.
Go back.
So, potassium nitrate. Find that on your sheet. Does that have an S or an I or a P? This is good practice to use your tool to figure out what's happening here. Potassium nitrate. It's an S. What does that mean, though? How do we translate that to this equation? If it's an S, how do we note that on the equation, though? Soluble, but we don't have a soluble thing on an equation. What are our things that we can put down below our products? S would be what? Solid, which, is this a solid or not? If it's soluble, it's not a solid. It would be in solution. So what do we have for something in solution with water? AQ.
Do we have to write that?
Yep. This is how you denote that this is soluble. It's still just in water. This is in that drop. If we go back to the drop picture, there's potassium nitrate just in the drop, dissolved in the drop. Now let's check lead hydroxide. Lead hydroxide is insoluble. It has an I if you look that up. And it must. If this is soluble, right, and in that drop we had some kind of cloudiness, some kind of solid precipitated out, then this one must be the precipitate, but we're going to check it anyway. We're looking at our purple chart, and what do we find? Insoluble. So here you would write in parentheses a little down arrow because it precipitated out like rain. It rained out of the drop. To your point, alternatively, guys, stay with me here. Alternatively, you could have put an S in here, right? Because this is a solid, it dropped out. It might still stay cloudy in the drop, but ultimately, that's what a precipitate is. Something not being soluble and dropping out of solution. So you would have this little down arrow. Now, we didn't list it, but let's play make-believe. What would you put over here akin to these for both of these substances on the left? What would be the state of these two things? Solid, liquid, gas, aqueous, which should it be? Aqueous, why?
Because they're dissolved in the water.
They were dissolved in that solution. Those little dropper bottles that you had definitely had something dissolved in them. Sometimes they had a little bit of a color tint or whatever, but you couldn't see those individual particles, right? So that was dissolved. So both of these would also be aqueous. But then when we mixed them, one of them got cloudy and fell out of solution, and that would have been this one. Now, plenty of the drops that you did yesterday, plenty of the boxes on your sheet did not have, just stayed clear, right? Any of these that stayed clear, no reaction happened. You just had all of those different ions floating around in aqueous solution. right? There was no specific reaction that happened. They just stayed in solution. Think of taking some salt water and some sugar water, both dissolved in water, and just mixing them together. You would still just have a clear solution. Might taste awful, but it would still be just a clear solution. However, when we mixed potassium hydroxide and lead nitrate together, both aqueous solutions, it got cloudy and one of those things fell out of solution. So we had a reaction. This is kind of the point of double replacement reactions, the point of the lab we did yesterday. Some of those things we mixed together, nothing happened. Right? But some of them we mixed together and you had that yellow drop, a pink cloudy drop, you had gas released in some of them. That is how you do this sheet. So you still have 15 minutes in class. You'll want to get together with your lab partners, start hammering out what these are. If your lab partner evaporated from yesterday to today and they have your sheet, I have extras. You can start working on what this write-up is so that you have this for tomorrow. You also have logbooks due tomorrow. Henry.
How did the lead hydroxide go out of it?
So over here, lead nitrate is soluble,
Yeah.
okay? And potassium hydroxide, soluble. They're both just clear liquids. But you mix them together and all of a sudden, as soon as this forms, as soon as these ions smash into each other, they create a compound that is no longer soluble.
So that's why it falls out.
So it falls out.
Okay. So if it goes from something soluble to something insoluble, it falls out.
Yeah, it no longer is soluble. So like if you put sand into a cup of water, the sand would just fall to the bottom because sand doesn't dissolve. If you put salt into water, you put it in and it slowly dissolves, it disappears.
Okay.
Right? This, no matter how long you leave it in water, it's never going to dissolve. It's like sand. It's just going to stay a solid in the water.
Okay.
So that's how you could tell something happened. All these boxes where you had something that you couldn't no longer see through drastically change, those are just solid particles in that solution. Versus all these ones that just remained clear, that's just two, everything in there is soluble. Nothing fell out.
Yes.
Right? So that's why we're looking for that. So in your write-up, you're going to be writing the reactions for a bunch of these that happened.
Okay.
And you're going to use the coordinate system on here to figure out what two compounds you mix together and then do the end part.